Thanks, Dan. I'd like to welcome you all. Thank you, Dan. Thank you, Brian, for the opportunity. Like Dan already introduced me, my name is Vinicius Campitelli. You can say whatever you you can. I'm from Brazil. I live in São Paulo, like Dan also mentioned. And I'm here to talk to you guys about something that we all hate, which is right. So we don't need them anymore. We haven't actually needed them for a while now because of this standard. But even though it's a standard that has been around for a couple of years, it's still at early stages of adoption. But I'll get into it. So what we're gonna see here, what we're gonna talk about here, basically we're lost my first that I lost my focus here on my keyboard. Sorry about that. So we'll cover what is WebAuthn. We also cover I do care what is standard about, what's going on, who invented it, what does it look like, what it doesn't look like, what it actually does. So we also see what can be used with WebAuthn, what are the protocols involved. Actually, is WebAuthn a protocol? Is it a standalone protocol? Does it have something that goes alongside with it? We'll see it in just a few slides. We'll see about something called ceremonies. What are ceremonies and what are the ceremonies that are happening in WebAuthn? So that is something that we'll cover as well. And finally, how you can implement it. And you guys are gonna see that it's actually pretty easy to implement. So at least the browser stuff, the front-end stuff is pretty easy to implement. I'll tell you something, the back-end stuff, it's a bit harder. So let's start saying what is WebAuthn. It's another way to authenticate. So since the invention of computers, of personal computers, we do have a way of authenticating ourselves. So WebAuthn is just another way to authenticate, right? It requires something called an authenticator. We're going to get a good look of what is an authenticator in a few slides. So just record the information that we require something called an authenticator. These authenticators, they hold the great part of the cryptography, like the private keys. We're going to see about them in a few minutes. And it's what actually the browsers interact with. But we get to it, so hold on a bit. And like I said, the main purpose of WebAuthn is to remove the need of a password. So I'm going to tell you about a bit about the histories of passwords and why passwords stink and why we don't need stinking passwords anymore. But the idea is to replace passwords when authenticated and used. Right? So it's pretty much all about standards. So I'll talk to you guys in a bit about who created, who is maintaining this protocol. So you guys gonna see that it's all about standards. And why is that secure? How can we replace passwords with something and still maintain the security? It's because we use public and private key pairs, right? So we use asymmetric cryptography to handle the authentication process. And I'll tell you guys why that's something of concern. Why is that something that you want to do in your apps? So to start, I'll just go off topic a bit to explain a little bit of something called a man-in-the-middle attack. So imagine that there's someone named Alice, and Alice wants to talk to Bob. If you guys are not familiar with these names, they are very common in cryptography, right? So instead of saying person wants to communicate with another person, or system A wants to talk to system B, we just created a few placeholders. So Alice and Bob are these placeholders. So if Alice wants to send a message, let's say a message called M to Bob, right? So when Bob receives that message, how does he know that someone hasn't tampered that message? So imagine there's another person in the middle called Mallory, another placeholder here for cryptography stuff. That Mallory is is an intruder is someone that has an evil goal, and it's eavesdropping the communication, but not only eavesdropping, it's actually replacing and modifying the message that Alice was about to send Bob. So instead of that message M, Mallory captured that message and changed it a bit, or changed the entire message and send another message to Bob. So how does Bob know that that message really came from Alice? There we have public and private key pairs. So imagine that Alice generated a key pair, public and a private key. Alice would need to send her public key to Bob. So Bob would store Alice's public key in his computer, in his system, in his application. There are a lot of algorithms to do that. Probably the most common is the Tiff-Hellman key exchange. But in this scenario, Alice would have her key pair, her private part of the key pair, secure her in her own device, and Bob would have Alice's public key pair. So whenever Alice wants to talk to Bob, wants to send a message to Bob, she would just send a message and sign her message with her private key. The signature, for those of you who don't know, the signature is a hash for the message, but it's an authenticated hash, so it uses that private key from Alice to generate a hash based on the private key. But Bob has Alice's public key pair, so Bob can use that public key to check the signature, to validate the signature. So whenever Bob receives a message, he receives both the message and the signature. He checks the signature with Alice's public part of the key pair to check if they match. So if they don't match, which would be the case if Mallory or someone else would do something weird in the middle, like changing the message, the signature wouldn't match because Mallory doesn't have Alice's private key. Private key is called private because you don't need to send it. You have to store it in somewhere secure in your servers, in your server, in your device, in your computer, your phone, or something like that. So even if Mallory could be somewhere in the middle, like I said, it's called a man in the middle attack. So if Mallory is eavesdropping the network connection, is hacking the Wi-Fi or something like that, Mallory doesn't have Alice's private key, so he can't generate another signature for that message. So when that message comes to Bob, Bob is gonna check the signature and they wouldn't match. So Bob could discard the signature and hey, this is not what I'm expecting. You are not Alice. So I'm done talking to you. So this is pretty much what public and private key cryptography, or like I said, asymmetric cryptography is all about, right? And this is the main standard for SSH, for TLS, and a lot of secure communications all around the internet nowadays. So this is something that relies on heavy math to actually do some calculations. We have the most common algorithms are RSA and elliptic curves, which require a large power, computational power to actually calculate the large numbers or these third-degree equations. So this is something very hard to do with the computers that we have nowadays. So this is the most secure way of talking to other computers or other systems until we have quantum computers in our house. But let's hope we can have a few more years of this standard cryptography right now. So the signature wouldn't match, and Bob would be just discarding that match. So this is what public-private key cryptography is all about, right? And that is what Web often uses under the hood. But before actually going to that, let me talk about something called FIDO. FIDO is a global organization. It was created in 2012, July 2012, if I'm not mistaken. It stands for Fast Identity Online, so it's an acronym for Fast Identity Online. It was a joint effort between huge companies, if I remember correctly, PayPal and Lenovo were some of the companies that were there in the beginning for FIDO. And their main goal was were to create a protocol for authentication without passwords. So they would call it passwordless authentication. A few months later, Google and Yubico joined. I don't know if you guys know Yubico, but it's a huge company that creates some cryptographic keys, and everybody knows about Google. So they joined the FIDO Alliance, which is that organization. But their goal was to create another protocol. They didn't join the FIDO Alliance to work on the passwordless protocol. They joined to develop a second factor protocol. And Google started using that protocol with their employees back then in 2013. And so FIDO, like I said, it's all about standards. It's all about creating passwords, authentication process, and protocols that are secure and they're usable for the web. So actually, this is part of another called FIDO 2. FIDO 2 is the second version of a standard, and it's also a part of two other protocols. So WebAuthn is just one protocol. It has a complementary protocol that we just take a quick look at it. We won't get much too deep with that, but basically WebAuthn is a joint effort between the FIDO Alliance and W3C. So W3C, for those who don't know, is the Worldwide Web Consortium. Pretty much is the global organization that is responsible for web standards like HTML, CSS, and XML. And their goal, when they decided to join FIDO in order to create this protocol, were to standardize their protocol across all web browsers. Right? So this joint effort, this joint venture, would become what we know as FIDO 2. Like I said, it's something that we still haven't heard about it a lot. When I say we, like the common developers that aren't too much aware of crypto, but it's actually been a while for a few years, right? So it's been around for a few years now. It was first submitted to W3C in 2015. So 8 years ago, it was the first draft. It achieved the candidate status for the specification in 2018. And it was finally standardized in 2019. So it's been a while for at least 4 years of stable release, right? Let me just check something here. People are saying that my audio is a bit weird. I can just please let me know if better. I try to grab the mic closer to my mouth. Okay. So besides WebAuthn, there's another protocol called CTAP, and I'll show you guys in the next few slides what's the difference between WebAuthn and CTAP, what do they do, and how they complement themselves. But imagine that you have an online store. We'll call it the Cosmos Clown Store because we're good at naming stuff. So you have an online store, it's the Cosmos Clown Store. You want to sell some stuff. So you communicate with the browser, right? Via HTTPS, I hope. If you don't use HTTPS in 2023, please do. Let's Encrypt has been there for a while. Caddy has been there for a while. So please use HTTPS in your websites, in your APIs, in whatever backend you have, and your front ends as well. And the browser is going to communicate with something called the authenticator. I told you guys earlier about the authenticator. I won't explain much of it, but it's kind of a physical device or a virtual device that we will hold all the calculations. But we'll get into that in a few minutes. So patient. So pretty much that's what the user will interact with. So the user will interact with the authenticator will interact with the browser, and the browser is going to interact with your online store, with your app, right? So WebAuthn is all about this part of browser and your app communicating with each other. So WebAuthn just about that. And CTAP is the other part of this diagram, right? So CTAP is about the protocol between the browser and the authenticator. Actually, CTAP is an acronym for Client to Authenticator Protocol. So pretty straightforward, right? Just say what they do. So we do have these two protocols that go alongside each other, but we are not developing browsers here. I don't know about you guys, but I'm not. And I'm not developing any hardware devices to hold cryptographic values. So I won't talk much about CTAP. I'll focus on web auth. But you may ask me, hey, why do I need to care about this? I already have a login process. I already have a form there with user and password. I already implemented two-factor authentication via email or via push notification or via a Google Authenticator app or something like that. So why do I need to change my app to do that? So again, let's go back to our store, our Cosmos Clown store, where people want to buy eccentric things, like clown stuff, right? But they have to log in, right? So pretty much what your app already does. So they have to log in to see their status, to see the history for the purchase they made, to save some items that they do want to buy in the future, like clown noses or something like that. Maybe they want to purchase some funny hats for their own circles, like that. But you want to focus on your audience. Your audience is not someone that is a heavy user, not a hard user for in computers or in smartphones or something like that. So it's not a tech savvy people. So they're not a tech savvy audience. So you want to ensure that the users can log in because you need to protect the resources, but you also have to make sure that things are easy to log in. Because one of the most frustrating things that we have is when we are about to buy something and we have to log in and we forget our password. So we have to go there and recover our password. That sends us an email. We don't have passwords to access anymore. It's an old email that we created like 15 years ago and we don't remember the password. So not easy, right? Passwords are not easy. Passwords, they have been around since the mid 60s. So passwords are around for 60 years now. And they are hard. They are hard to balance for a user because, especially for users that are not heavy users, like I said, because they can be simple enough, because otherwise other people would guess it. Funny story here in Brazil last month, there was a data breach, and like our DOJ, the equivalent for US DOJ, had a data breach, and the hacker just went to the jury and he said that he found passwords like 123 change in Brazil's DOJ. Someone really left 123 change password there. So that sorry. But passwords should be simple enough for the user to remember, and at the same time, they should be hard enough for a hacker or a assistant or someone so it doesn't crack it, right? So it would take a couple of years or thousands of years to crack a password. So it's very hard to get to this right amount of balance. One curiosity, I don't know if you guys know about it. I hope you do, but there is this website called Have I Been Pound, and great website. I suggest that if you don't know it, please register yourself there. It's pretty much a unique location that informs people, that tells people when there's a data breach with their email. So if your email was ever being hacked, Have I Been Pound is going to notify you saying, hey, your password has been leaked in a data breach from company X. So please go there and change your password. Make sure to change all the passwords as well. So it's a great website, and it has 12.6 billion accounts that have been leaked there. So passwords are hard. They get reused, right? People use the same password. I don't know you guys. If you guys do that, please don't reuse the same password, right? create different passwords for your different services. So just a curiosity, the first digital password that we have record of was in 61, I'm sorry, 61, in a system from MIT called CTSS. If I'm not mistaken, that's supposed to mean compatible time sharing system. So it was the first system to ever use a password. And the first data breach was in 65 in that same system. So the first system to ever use a password was the same system to ever have a data breach for the password. So interesting, right? That's why I said that passwords stink, because it's easy to get a breach, get a data violation, get a leakage or something like that. So and criminals like the clown, not the IT clown, but the IT clown would love to put their hands on databases that would have passwords or backups that aren't encrypted that has our passwords. So we should go to other alternatives, right? So what are the alternatives that we have? And thinking about it, actually, they stink too, because like I said, for people that aren't very tech savvy, if they use password manager, I don't think that non-hard-end users use a password manager. But if they decide to use one, it's very hard to get it right. And there are a lot of options in the market. But if you don't have a central server like a cloud server, you're gonna have different passwords on your phone, on your laptop, on your tablet, on your desktop, your home, or desktop for your workstation or something like that. So it's very hard to synchronize all those passwords, right? Another thing, who watch the watchers, right? There has been a lot of data breaches in those password managers as well, because it's a very, very valuable target, right? So imagine for those scary folks, for those it clowns, those scary folks, right, from the previous slide, they would just go after these solutions because they store passwords for thousands or millions of users. So they're very, very valuable targets. And I've been using password managers for a while now, and some sites they don't work well because if the farm login doesn't have a very good experience, like they don't name their farm fields correctly, so maybe the app doesn't know about it and can't autofill the password because it actually can't see that there's a login there with a username and password combo. Or maybe there are some forms that first ask your email or your user, and the next step is going to ask your password. So some non-standard login forms can break those apps as well. So you have to go there, copy the password and paste it. So it's not a very good experience for the user. Okay, but I can add a second factor of authentication, right? So I can add multi-factor authentication. Of course, that is great. You should add multi-factor authentication to your apps. But again, it's another very hard thing to get it right because of the UX. Because you can have some experiences that aren't that great. Like, hey, I'm about to buy something. I need to grab my username, my password, and I need to go to my phone, open the Authenticator app, and type a code from there, like a 6-digit code or something like that. Or I received a code in my email, I have there and type the code. Those on-time passwords, which what are these codes are about, they have a window, a time window that they are valid. So maybe if your clock on your computer or your device is not synchronized, it's gonna get you wrong code. So not that easy, but again, you should add it. Even with two-factor authentications, there are some methods that aren't that safe, like SMS. SMS are are very widespread, but they have some security flaws, especially when targeting some other countries that use some older versions for the protocol. Again, here in Brazil, a couple of years back, we had a minister who had his data, who has his cell phone hacked with some, it's due to some SMS flaws. So take care of when sending codes via SMS, prefer emails or push notifications or the standard Google Authentication app instead of SMS. Users can be phished, right? Users can receive a phishing email saying something, asking something. So it's a very easy thing to do. That just call, so someone could call the person and say, hey, you just received a code. I need to type that code here to continue with the sale or continue with the support, or in order to win a prize, author prize or something like that. So there are a lot of phishing campaigns. So users can be phished, right? And another thing that we sometimes forget, that we also have to require two-factor authentication in some scenarios. We also, besides just the login process, we should ask for the two-factor authentication in some parts of our system that requires like a change for the account, like changing the credit card or changing the email or deleting the account. So those are processes, those are workflows that should require factor authentication. We call that step-up authentication. But there aren't a lot of people that remember to do that. They just put the two-factor authentication process in the login and they forget about these parts, right? So again, it's a great feature, but it's easy to get lost. We could use an SSO, a single sign-on process, so all of our authentication and authorization policies would go in that system. Like everything, we don't have bulletproofs, we don't have silver bullets. Everything has a problem, and in this case, it's because you're depending on a third-party service. If this third-party process goes down, you don't have login anymore, or if you have something going on with the business part and you need to deal with a new contract or something to maybe some part of the negotiation for the new year or something like that. What happens if the third-party solutions ask for double the price, 3 times the price that your original paid? So it's hard to depend on someone else, but again, all these things have their pros and cons. So it's just like a matter of fact of balancing them and waiting them, and that is something that WebAuthn offers. So this peaceful feature of rocks here, because WebAuthn offers balance. The first thing, it offers security, because it, like I said, it's the same technology that is used in SSH and in TLS, are the private and public key cryptography. It's only available on TLS, so you can enable it in a HTTP only server. So in this case, those information, data information is not being transmitted in an insecure channel. So that's very good. Another thing that we're going to see, we have something called the relying party ID. I'm going to take a look at it pretty soon. But the browser itself is going to validate the information that is being transmitted with the domain name for the site that you're browsing. So you can phish users using a site that looks like your site. Just change something in the URL, something, because the browser itself validates the domain name. It's not part of the developer to do that. So it has a standard secured process which the browser does. Like I said, a lot of very smart folks worked on the standard. We have Fido with Google, PayPal, Lenovo, Ubico, and we have the W3C together with them. So it's very secure and it's very safe to use that. And another thing that's very cool about WebAuthn is that the actual meaningful piece of information stays with the user. The server side only stores public keys, like I told you guys in the Alice and Bob communication example, right? Bob only stores Alice's public, and someone can't do anything with the public key. The private key is the meaningful part of communication. So even if someone could get their hands on a backup or the actual database dump for your server-side application, they couldn't do anything with it because, like I said, the private keys stay with the user, so they have nothing to steal. That's very cool, right? The user experience is better because the process is built in browsers, so they would have a standard way of logging in and registering in applications via browser interface. So we wouldn't have that so different user interfaces for the login process itself. So if someone uses Safari or Chrome or Brave or Firefox, etc., all the login process would be the same. After the login button is clicked, it's all the browser that does the heavy lifting. So that's pretty cool for user experience. Another thing that there are no passwords to lose because you don't lose passwords. Again, the private key is going to be stored in the authenticator. We will see it soon. And it's phishing resistant. Like I said, the browser validates and verifies the domain name. So someone can't just send you an email saying, hey, I'm Cosmos Clown Store, but with a Z in Cosmos. I need your password or log in here to see our latest update, or there was something wrong with your purchase. Please log in to see updates. It wouldn't work. Browser would verify the domain name, right? So, and another very cool thing that I will say again in a few minutes, it can combine two factors in one. And I'll explain a bit more about it when I talk about user presence versus user verification. But it can combine two aspects of security. So that's pretty cool. Hold on to that thought, and I'll get back to it in a few minutes. Another very cool thing about WebAuthn is that T-Mobile they went to this conference called Identiverse. I don't know if you guys heard of it, and they showed a report that they have implemented WebAuthn in their app, and they made a survey with their users, and it seems like 80% of the users using WebAuthn methods instead of password. So we have a huge company, a real market base with users that actually are preferring WebAuthn, and we'll talk about what are those methods like biometrics, entry, or something like that, instead of actually having to type them. So that's pretty cool, right? But that doesn't work, man. That doesn't work on Safari. That doesn't work on Firefox. That doesn't work on Chrome. Actually, it does. Pretty much all the major browsers from even versions from the last 5 years have support for WebAuthn, so it's pretty cool. You can go to canIuse.com and check for WebAuthn, but pretty much every browser, desktop and mobile devices versions for those browsers have support for WebAuthn, so it's pretty widespread. Okay, so finally, enough with the chit chat. Let's get more into the protocol itself. What are the players involved in this process? I showed you guys a diagram before, so you guys already know some of them. So we have the user, of course, someone is trying to log into the Cosmos Clown Store. We have the browser, everything that's web-based has a browser. So we have browsers here. And we have our website, would be the Cosmos Clown Store, right? So instead of saying website or API or backend or something like that, we have all these names, right? The standard itself calls this a relying party. So every time I say relying party or RP, remember that it's actually the backend for your app. Okay. Yeah. Here's our Cosmos. Here's Cosmo, admin for a web store, right? It's about to get some real customers buying from his store. And we have this authenticator, which again, I know that I said it 10 times before, but I'll get to it in a few slides. I swear to you guys, it's almost there. So how does that work? How does this authentication process work forward? So the user would click a login button, and the browser would talk to your app, to the JavaScript in your app, our front end, saying, hey, user wants to log in. The backend for your app should send a challenge. A challenge is a random string of bytes that should be really random, so don't use timestamps or IDs or something like that. So just use whatever language or framework you're using in your backend to actually generate a random string. And also, you should send some other information that's part of the protocol. I'll show a bit of them in a few slides when I show you guys the code. But you have to send what called the relying party ID, which would be the domain for your app, like cosmoscloudstore.com. And we have another part, the protocol itself. You can have some constraints on which kind of authenticators you want to support, but let's just call other stuff. So let's focus on the challenge, the random string challenge, and the relying party. So the random challenge would be something like that. So just a bunch of random strings coming from their backend. And the relying party ID would be the domain name for your app. So cosmoscloudstore.com. Then this is where CTAP comes in. So this is part of the CTAP2 protocol. So the browser would talk to the authenticator. Again, this is authenticator that I keep talking about, right? So the browser would start the protocol with the authenticator and say, hey, I need to generate a new login process here. Here's the relying party ID. Here's the challenge, the random strings that I want you to sign. And here are some other information about the protocol, about the algorithms that you want to use, something like that. And the browser would say, I would want back an assertion. I would get to what is this assertion in a bit, but it's pretty much like a signature, like the one I mentioned in the Alice and Bob communicating diagram. So the authenticator would generate a signature for that user, but wait a few slides. So this authenticator device, which would be a hardware device or a software device, would ask for the user for the authentication. So that's what the cool part of the whole FIDO2 process is all about, because these authenticators, they are already present in our days, right? So we have Face ID, we have Touch ID, we have Windows Hello devices, we have the Android fingerprint for Android devices. So these authenticators that are sometimes built in your devices, they already have this biometrics requests that pretty much all of us already has done it before, already did it before. So, but some authenticators actually want some PIN entry or some other type of presence. So the user could say, hey, I'm here and I approve this request of logging to that cosmoscloudstore.com. So the authenticator will generate a private and a public key pair, but that's part of the registration process. I'll get into that, but here's the login process. So the authenticator would grab the private key that it has stored safely in his device. So remember, private key doesn't ever leave the device, so it's pretty secure. So the authenticator uses the private key that he has stored for the Cosmos Cloud Store, and it signs an assertion. I'll get into what is an assertion in a few moments, but it's pretty much, again, like I said, it's like a signature for a message, and the browser would receive that signed assertion. So here's where some of this stuff for WebAuthn gets a bit nasty, because the browser would have to send those informations to your web app. So maybe you should do a post request to an API endpoint with those data, with those information, with those fields, and we should present the signed assertion, which again would be the signature. But I'll explain in a few moments. I know that I've been saying that a lot. You guys are patient enough to wait for it. And here's what we can grab back from the Alice and Bob example again. The Cosmos Cloud Store, which would be your app, should have the user's public key with it, right? So I'll get back to it in a few moments. But imagine that the Cosmos Cloud Store already has the public key for that user. So when that signature came, when our browser sent that post request to your app, the Cosmos Cloud Store would retrieve the public key for their user and say, "Hey, I know Vinicius. You already registered here before. Here's his public key. I'm gonna check if the signature matches with the public key that I have stored for him. And if they do match, I can finally go there and say, welcome Vinicius, you are now logged into the Cosmos Cloud Store, right? So this is what the authentication, the signing process looks like. I'll talk about the code right now, and I'll talk about the registration process in a few moments, because we need to have a way to take that public key to the app, right? But that's pretty much how the login process works. So it's pretty straightforward, right? And the cool part for me is this one, right? The Face ID, the Touch ID, the PIN entry. So this is what replaces password, right? Because the authenticator would have to ask for your face or for your fingerprint. So this is what replaces password, right? Let's go back to where we were. Let's give a pause to our happy clown here, and let's get deep into some JavaScript. Again, it's a browser API, so everything, like 90% of the things run in your browser with JavaScript. And the cool thing for this API is that it's very simple. They have good naming for their functions, their return objects, and something like that. So I really like using those APIs because they are pretty straightforward. Like the main entry to sign in a user, you just have to call navigator.credentials.get. So it's pretty cool, right? So you just need to have one call to the browser API. I'll get into those options in the next slide. And that's where the heavy lifting is going on. But as soon as you run that code in JavaScript, the browser would come in and start the CTAP2 protocol with the authenticator. So from that moment forward, it's all about CTAP2. You don't have to worry about it as a web developer. You just have to wait for it to come back, to return. It's a async function. So it's gonna resolve. It's a promise that it's gonna resolve with some options, with the responses for your options. So that's pretty easy. That options in between parentheses, they are what I told you guys before about the challenge. So pretty much is an object where you have to tell the browser what are the relying party ID. Remember that I said, you guys, RP, relying party. So it's pretty much the domain name for your app. Then you would also need to send the challenge that your backend returned. So I really recommend that you guys send the strings from the backend instead of the front end. Front end doesn't have a truly random algorithm, but backends do. So please just call your API and it should return a random challenge. And then you can also ask about user verification. I'll talk about a bit, but it's two different types of asking and making sure that the user is there. We have user presence and user verification. but it's pretty much a way of making sure that we really have a human there using that device, that computer, that phone, or something like that. But I'll explain a bit further. So you pretty much call navigator.credentials.get, test all those options right here, and it's going to resolve, right? It's very simple to do. The protocol itself, of course, it has a lot of other features that you can implement here, and I'll get a bit into that when registering, but that's pretty much it. So pretty cool, actually. So when it resolves, when the promise resolve, it's gonna resolve, gonna return this assertion response object. It's pretty well documented, and it has a lot of information about the authenticator, about the user, about the public key that's being returned. And then when we receive that response from the authenticator, we need to have a way of getting that, which would be the process to our backend. So like to a post request to an API, to a /login endpoint or something like that, saying, hey, here's the response for the login process that you asked. Here's the public key for the user, something like that. But I'll get into it. And that assertion response object that resolves in the promise, put here, which is the assertion response, it is an object that has a lot of cool stuff about the authenticator. So it's an object with pretty much 3 entries. The first one is about the authenticator data. So it has the relying party ID, it has some flags, it has the process of the process which would be webauthn.get, which would be the actual signing. It has the signature for the certificate, and so it's pretty easy to resolve. Here, so again, there are a few nuances here. There are a few caveats here. Pretty much all these information they return in some byte arrays in JavaScript. So kind of boring and difficult to transform into byte arrays and go back to byte arrays. But the process itself, it's pretty simple, right? So again, it's just a navigator.credentials.get call, and then you would just go into this object and verify it and send it to your back. So that's pretty much it. I see that some people that are asking about the authenticator, and finally we come to the slides that authenticate. What are authenticators about? So there are several types of authenticators. The most common ones are external hardwares, which would be YubiKeys or another device that you can plug in via USB, via NFC, via Bluetooth. So you can connect to your computer, to your phone, to your laptop, or something like that, to your tablet. So the good thing about these external hardwares, that they are cross-platform, right? So they work with your Windows computer, with your Mac computer, with your Linux computer, with your phone. If they have NFC or Bluetooth, right? You can plug in a USB to your phone, or if they have Bluetooth. So that's pretty cool because you can use the same key for different devices. So we have YubiKey, we have solo keys with Trezor. Google has Google Titan, if I'm not mistaken. They start a bit like maybe $20 or $30, if I'm not mistaken. Here in Brazil, they are a bit more expensive than that, but if I'm not mistaken, they are like $30 or $20 in the US. So not that a big of a deal, right? And they can hold hundreds of credentials there. So pretty cool. But softwares, your own operational system, they also have this kind of authenticators, like Windows 11, if I'm not mistaken, always comes with a TPM, Trusted Platform Module, which would be responsible for storing those keys. Mac devices also come with them, so you can use Apple's Touch ID to store keys. Android phones have the TPMs built-in. The newer devices have TPM built-in as well. So you don't actually need to buy those external keys if you have new devices from the past few years, like Windows 11 or the newer Mac and Android and iOS devices. So you can use the built-in solutions for your own platform. That's pretty cool, right? The only found that I would say is different from those external hardwares. They are built into your software, right? So it's not easy to get a key from an Android phone to another. So if you ever lose that Android phone, you are losing those keys. But WebAuthn has a new standard that's trying to bring down synchronization for the key. So even though you're using the built-in module for your device, for your platform, you're still gonna be able to synchronize with the cloud and restore it if you ever lose the device. So that's pretty cool. And also, Google Chrome has a virtual device where you can enable from the console. So for developing purposes, you can just open the console, you go to more tools, if I'm not mistaken, and you can enable WebAuthn there, and you can create virtual devices to actually store and retrieve credentials. So that's pretty cool. I use that a lot for development. So if you guys want to see how that works, just open your Chrome console and enable WebAuthn. Like I said, browsers, they use CTAP2 to communicate with those authenticators. So it's not part of this talk to talk about that, because we're not building devices, we're not building browsers, we are building web apps, and that's what WebAuthn is all about. I know that I have a question slide here, but due to our time, I'm going to skip it and just talk about the ceremonies, and then we can leave room for some questions in the end if you still have time. So basically, ceremonies are the process of logging and registering. They have some cryptographic features as well, which we'll call attestation and assertion. Basically, whenever the browser calls the authenticator to sign the message for a login or for a registration process, the authenticator should return a certificate using the private key that created, and that certificate has a lot of information about the device. So you can know if the authenticator is a YubiKey. You can make sure that the authenticator is using elliptic curves, or you can make sure that the authenticator is not a virtual device or something like that. So even though you can just leave these settings unrestricted, you could have some sort of constraints to make things even more secure, even more restricted. But personally, I would only recommend this kind of constraints if you are creating like a banking app or something for the government, because it requires a high level of security or something like that. Because if you know too much about the authenticator, you could have some problems with the GDPR because you're storing data for the user. So even though you could retrieve and save information about the user, license user authenticator process, I don't recommend doing so. Okay. So the authentication is, like I said, just that simple process, and the difference between registration is actually that the browser would need to send the user's public key to your Cosmos Cloud Store, right? So remember when Alice was talking to Bob, needed to send her public key to Bob. Here is the same thing. The browser needs the browser receives the challenge from the backend. That's the challenge to the authenticator, and the authenticator calls the user for Face ID, Touch ID, or something like that, and then generates a key pair. It will securely store the private key within the device, and it would return the public key with a certificate to the browser. So the browser could send that public key to your backend, and then your backend should register that public key under that username. So imagine if I'm registering for Vinicius.campitelli@fusionoff.io, and I receive that public key for Vinicius. I know that every time that Vinicius wants to log in, he would have to send me some information that I can check with the public key. So it's pretty much the same Alice and Bob example. Right? There are a lot of other few things that you can do. You can have several public keys for the same user. It depends on the business logic that you have. Maybe you don't want to allow that. Maybe you just want the user to have a single source of login, like their app or something like that, their phone. So if you want to allow more than one login, more than one device for a common cloud store, I would say that you don't want to have such higher constraints or requirements for security. So you could allow the user to register several public keys for his username. That's also pretty cool, but it's part of more of a business logic for the backend itself and not part of the protocol, but it's a fun thing to mention, right? So this process is, the cool thing is, each website, whenever there's a process of signing up, the authenticator is going to generate a key pair for that specific relying party. So it has private keys for Cosmos Cloud Store, for purpleisgray.com, for Amazon.com, for CFE.dev. So it has different private keys for each one of those sites, right? Just to finish things up, the registration entry point for your browser API is pretty much the same. The difference is between not get anymore, it's create. So you just call navigator.credentials.create, and you should pass those options, which would be the relying party ID, the user name or user display name, the challenge that your backend created. You can also say that you want to use elliptic curves with DSA. So that's what that -7 stands for. That's an algorithm identifier that stands for ACDSA. So you can have such constraints. So that's pretty cool as well. So you say the relying party, the user, you turn the challenge from the backend, and you have some constraints about type of algorithm that you want to allow. Again, it's a promise, so it's going to resolve to the new credential info, and that new credential info has some type of information, like the challenge, and it also has this object called the attestation object, which has the credential ID, the credential public key. This is the object that you need to send to your backend, right? Because you're registering the user, so you need to send this information to the backend, so the backend can store it in their database. Again, the only thing that is stored in the database is the public key, so not valuable at all. The only thing that can generate certificates are the private keys that are safely stored inside the authenticator. So very secure. Normally, we use WebAuthn when registering. We need to ask some other kind of information, so the user could ask, so the app could ask the username or the email to associate that public key, right? So imagine I go to Cosmos Cloud Store, I click I want to register, the store would ask, okay, so what's your username or your email? I would fill in my email, and then when I hit next, it would send some information to the backend. The backend would return, okay, I want to register the user, here's the challenge, and then sit that. So yeah, sure. I'm just being told that took a lot of time. Sorry about that. So I'm almost there. So there are, like I said, you could know a bit more of the authenticator. Every authenticator has a certificate, so you can go to this website right here, which is a metadata service for authenticators. So whenever there's a certificate coming in for a backend, you can see exactly which authenticator was used. For instance, Windows Hello hardware authenticator always come in with this specific public key. So in this JSON file, which is a huge JSON file, each is 64 it's a base 64 encoded JSON file with all the authenticators. But again, I don't recommend doing this attestation process to GDPR issues, right? And again, just it can be used as a second factor of authentication due to something called user presence and user verification. So user presence is when the user has access to the authenticator, right? So it's connected via USB, via NFC, or via Bluetooth. But you can go one step ahead and ask for verification, not only presence. So verification would also ask for the user for a PIN or for fingerprint or for his face to be a face ID or something like that. So my tip here would be, if you are just authenticating, use just verification and require verification, because the user will have to touch the fingerprint, or the user will have to open the camera and hello, smile to Windows Hello or the Touch ID or the Face ID app. So if you're authenticating, use verification. When using as a second factor, just use presence. I won't go over resident keys, I'm sorry, but it's pretty much a way of storing user information in the authenticator. So like I said, it's pretty much going back from byte array in JavaScript to basic support. That's not very easy to do, but as soon as you get how it's done, you get used to it. Yeah, so I have to wrap things up. Again, WebAuthn allows users to authenticate using strong authentication protocols without passwords, using fingerprints or your face. And with that, users are happier because they can buy your funny hats or funny clown noses in your store easier without having to remember a guest password, right? So thank you guys. Sorry it took so long. I had a lot of things to say. So here are some resources. You can check the standards at w3.org. Mozilla, as always, has great docs about the web authentication API. And here's my social media handles. I'm at Campitelli, whenever you can find Twitter, GitHub, Instagram, and FusionAuth. We have a lot of guides on authentication as well, so you can check us on fusionauth.io. That's it.
Vinicius, that was amazing. Thank you so much. Right? You covered a lot. I know you had to skip some things due to time constraints, but really appreciate kind of the in-depth look at that. So thank you, Vinicius, and thank you everyone for joining us for this session about how we can avoid stinking passwords. So